Welcome to our channel. Today we're diving into the fascinating world of artificial intelligence. We're talking algorithms, neural networks, machine learning, the whole shebang. It's getting pretty crazy out there, so we're gonna break it all down for you. From the AI that powers your smartphone to the advanced systems driving autonomous vehicles, we'll cover it all. We'll explore the different types of AI, how they work, and the potential impact they have on our lives. So, whether you're a tech enthusiast or just curious about this game-changing technology, this video is for you. Buckle up because things are about to get interesting. Alright, let's kick things off with narrow AI, also known as weak AI. This is the type of AI you interact with every single day, probably without even realizing it. Think about it. That facial recognition unlocking your phone, that's narrow AI. Your spam filter keeping your inbox clean? You guessed it, narrow AI. Now don't let the name weak AI fool you. It's called narrow because it's designed to excel at one specific task, or a very limited set of tasks. It's like that friend who's amazing at playing a certain musical instrument but ask them to cook a decent meal, and you're out of luck. But within its lane, narrow AI can be incredibly powerful. Take for example recommendation algorithms. You know, those things on Netflix and Spotify that seem to know your taste better than you do? They analyze massive amounts of data about your viewing or listening habits, and use that to suggest content you're likely to enjoy. And the crazy thing is, these algorithms are constantly learning and improving. The more data they have to work with, the better they become at predicting what you'll want to watch or listen to next. It's like having a personal assistant for your entertainment, constantly curating the perfect playlist or movie marathon. But it's not just entertainment. Narrow AI is also making waves in healthcare, finance, transportation, and countless other industries. In healthcare, it's helping doctors diagnose diseases earlier and with greater accuracy. In finance, it's being used to detect fraud and make smarter investment decisions. And of course, we can't forget about self-driving cars. While still under development, this technology relies heavily on narrow AI to navigate roads, avoid obstacles, and ultimately get us from point A to point B safely. So even though narrow AI might not be as flashy as some of the other types of AI we'll be talking about, it's important to recognize its impact on our daily lives. It's the silent workhorse, quietly powering so many of the technologies we rely on. But things are about to get even more interesting as we move up the AI ladder. So buckle up because next we're diving into the world of general AI. Okay, so we've talked about narrow AI, which is great at specific tasks, but what about an AI that can do it all? That's where general AI comes in, also known as strong AI. This is the stuff of science fiction, the AI that can think like a human, learn like a human, and potentially even surpass human intelligence. Now, when we talk about general AI, we're talking about a machine that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks, just like you and me. It's not limited to a single domain. It can write poetry, compose music, code software, and even understand complex emotions. The key difference between narrow AI and general AI is this. Narrow AI learns how to perform a task, while general AI learns how to learn. It can take its knowledge and apply it to new situations, adapt to changing environments, and essentially think for itself. So, where are we at with general AI? Well, the truth is it's still largely theoretical. We haven't quite cracked the code on creating a machine that can truly replicate the complexity and nuance of the human mind. But that doesn't mean progress hasn't been made. Researchers are making strides in areas like machine learning, natural language processing, and computer vision, all of which are essential building blocks for general AI. Imagine a world where you have an AI assistant that can not only manage your schedule and answer your emails, but also engage in meaningful conversations, offer creative solutions to problems, and even help you understand your own emotions better. That's the promise of general AI, a world where machines can work alongside humans as partners and collaborators, augmenting our abilities and helping us solve some of the world's most pressing challenges. However, the development of general AI also raises some important ethical and philosophical questions. If we do succeed in creating machines that can think for themselves, what are the implications for humanity? It's a topic that sparked countless debates and inspired countless works of science fiction, and it's a conversation we need to continue having as we venture further into the realm of artificial intelligence. But for now, let's shift our focus to the most extreme end of the AI spectrum, superintelligent AI. Okay, so we've covered narrow AI, which is great at specific tasks, and general AI, which aims to replicate human-like intelligence. Now let's talk about the big leagues, super intelligent AI. We're talking about an intelligence that doesn't just understand and learn like a human, it surpasses human intelligence in every possible way. Think processing power, problem-solving abilities, creativity, you name it, super intelligent AI would be off the charts. Now we're venturing into truly uncharted territory here. This isn't just about building a machine that can beat a grandmaster at chess or write a best-selling novel. This is about an intelligence that could potentially solve some of humanity's biggest problems, like climate change, disease, and poverty. But it also comes with a whole new set of questions and concerns. If we create an intelligence that's smarter than us, how do we ensure it remains under our control? How do we align its goals with our own? And how do we prevent unintended consequences? These are questions that philosophers, scientists, and engineers are grappling with right now. Some believe that superintelligent AI could be the key to a utopian future, while others worry about the potential risks. It's important to remember that superintelligent AI is still largely hypothetical. We're a long way off from creating anything close to it, and some argue that it might not even be possible. But the very idea of superintelligent AI forces us to confront some fundamental questions about what it means to be human and our place in the universe. It's a topic that sparks both excitement and trepidation, and it's one that we'll continue to explore as we delve deeper into the world of artificial intelligence. But before we wrap things up, let's take a step back and look at some of the more fundamental types of AI that paved the way for these advanced concepts. Alright, so we've journeyed through the world of narrow AI, general AI, and even dipped our toes into the vast ocean of superintelligent AI. But to truly appreciate how far we've come, we need to go back to the roots, the very foundation of artificial intelligence, reactive machines. Now these machines are about as basic as AI gets. Think of them as the pioneers, the ones that paved the way for all the complex AI we see today. They don't have memories, they don't learn from past experiences, and they certainly can't dream of electric sheep. Instead, reactive machines operate purely in the present moment. They react to specific inputs with pre-programmed responses. It's like a light switch. You flip it up, the light turns on, you flip it down, the light turns off. Simple, predictable, reliable. One of the most famous examples of a reactive machine is Deep Blue, the IBM chess-playing computer that defeated world champion Garry Kasparov back in 1997. Deep Blue was a marvel of engineering for its time, capable of evaluating millions of chess moves per second, but it was still a reactive machine at its core. It could analyze the current state of the chessboard and choose the best move based on its programming, but it had no memory of past games or the ability to learn from its mistakes. Another example is the spam filter in your email inbox. It analyzes incoming emails for certain keywords, patterns, and sender information, and then decides whether to deliver the email to your inbox or send it straight to the spam folder. It's not learning your preferences or adapting to your changing habits. It's simply reacting to each email based on preset rules. Reactive machines might seem rudimentary compared to the likes of general AI or superintelligent AI, but they played a crucial role in the evolution of artificial intelligence. They demonstrated the potential of machines to perform tasks that were once thought to be the exclusive domain of human intelligence. And they laid the groundwork for more sophisticated AI systems that could learn and adapt over time, which brings us to our next type of AI, limited memory AI. So, we've talked about reactive machines, the AI pioneers that operate purely in the present moment. Now, let's step up the AI ladder and explore limited memory AI, a type of artificial intelligence that can actually learn from past experiences to inform future decisions. Now, this is where things start to get really interesting. Unlike reactive machines, which have no memory of the past, limited memory AI can store and recall past data to improve its performance over time. It's like the difference between a student who forgets everything they learned after each class and a student who retains information and builds upon it. One of the most prominent examples of limited memory AI is in self-driving cars. These vehicles use vast amounts of data collected from sensors, cameras, and GPS to navigate roads, avoid obstacles, and make split-second decisions. But they also rely on limited memory AI to learn from past experiences. For example, if a self-driving car encounters a new traffic pattern or road construction, It can store that information and use it to make better decisions the next time it encounters a similar situation. It's like having a driver who's constantly learning and improving their skills on the road. Another area where limited memory AI is making a big impact is in personalized recommendations. You know, those eerily accurate suggestions you get from Netflix, Spotify, or Amazon. Those recommendations aren't just based on your current activity, they're also informed by your past behavior, your preferences, and even the time of day you like to watch, listen, or shop. Limited memory AI algorithms analyze this data over time to create a detailed profile of your tastes and predict what you're most likely to enjoy. It's like having a personal shopper or entertainment curator who knows you better than you know yourself. But limited memory AI isn't just about entertainment and convenience, it's also being used to improve healthcare, finance, and cybersecurity. In healthcare, it's helping doctors diagnose diseases earlier and develop personalized treatment plans. In finance, it's being used to detect fraud, assess risk, and make smarter investment decisions. And in cybersecurity, it's helping organizations identify and respond to threats more effectively. So, while limited memory AI might not be as glamorous as the idea of general AI or superintelligent AI, it's a powerful tool that's already having a significant impact on our lives. And as data becomes even more abundant and AI algorithms become even more sophisticated, we can expect limited memory AI to continue to play an even bigger role in shaping the future. And that brings us to the end of our exploration of the fascinating world of AI types. We've covered a lot of ground today, from the everyday AI that powers our smartphones to the mind-blowing possibilities of superintelligent AI. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more tech insights. We're diving deep into all things tech, so hit that notification bell so you don't miss out. Leave a comment below on which type of AI you find most interesting or any questions you have about AI. We love hearing from you guys, so let's keep the conversation going in the comments.